हेलो स्टूडेंट्स, मोस्ट वेलकम इन मैथ सीरीज एकेडमी। तो आज हम यूनिफॉर्म कॉन्टिन्यूटी की बात करेंगे और इट्स वेरी वेरी इंपॉर्टेंट टू अंडरस्टैंड द यूनिफॉर्म कॉन्टिन्यूटी। कॉन्टिन्यूटी के बारे में हम लोग जानते हैं कि फंक्शन कॉन्टिन्यूअस कब होता है, बट व्हाट इज द एक्चुअल मीनिंग ऑफ द यूनिफॉर्म कॉन्टिन्यूटी थ्रू आउट द इंटरवल, थ्रू आउट द डोमेन, वट एवर वी आर टेकिंग एज अ डोमेन। Okay, the uniform quantity. Let us understand first what is the continuity means. Okay, so if I'm just taking let, I'm just taking FB. If I'm just taking FB, a continuous, if a function, if B, a function, if B a function defined on a interval, an interval, I'm just said I. So I'm just taking a function f which is defined on an interval I. So what means the continuity at a point? Okay. So if we are saying, if you can just say, then by definition, then by definition, the function is continuous. So I'm taking the function is continuous at a point at any point P, which is from the interval I. So if we are taking any epsilon, should exist a delta such that this condition holds. So if for any epsilon positive, there should exist a delta such that this is mod of fx minus fc less than epsilon when we have this x minus c is less than delta. So what is meaning of, so if I'm saying a point is continuous at this point C belonging this interval, then for every epsilon, whatever we take the epsilon, we definitely able to find in delta such that mod of fx minus fc is less than epsilon when this x minus c is less than delta. It meaning that if you are just expanding this, you can have fx minus fc less than delta, and it is greater than minus delta, and it meaning this is fx should lie less than, this is fx fc plus epsilon, and this is fc minus epsilon. Okay, when this x is belonging to this interval, from here you can just get this is your x, sorry, t minus delta. This is t minus delta, and this is t plus delta. Okay, so whenever you take x in this interval, this value of the function should be lie in this interval. You can also say like this. This is fx is belonging to the open interval. This is your fc minus epsilon, and this is fc plus epsilon. Okay, so this is the definition. Okay. So here, if we are choosing any other point, I'm just taking it. Okay, so for other point, for any other point, if I'm saying, so this is the definition for continuity at a point C. If we are choosing any other point, for any other point, I'm just taking any other point D. Suppose that D in this R. So we will for this epsilon, whatever we are choosing this epsilon here. Okay, so for this epsilon, be able to find a delta, but it is not necessary it is equal to the delta in previous one. So I'm just said this is delta 1. Okay, there exists delta 1 positive. Such that this condition is fulfilled, that is fx minus fc, not fc, fd is here because we are taking d point. So fd is less than epsilon whenever this when this we can say this is mod of x minus d is less than delta. Okay, so obviously बात है this is continuous at point C and it is also continuous at that point D. Okay, but here this delta 1 is not necessarily is equal to the previous one. ठीक है, so it's not this delta 1 is not necessarily delta 1 is not necessarily equal to this delta in previous one. Okay, so it means that if you are taking the same epsilon, if you are taking the same epsilon, whatever you are taken here for the same points, other points. So this delta 1 will differ point to point. It may, it's not necessarily कि same हो, ये भी necessarily नहीं कि different हो, same हो भी सकता है, but in general, it is not necessarily this delta is equal to delta 1. It means point to point, this delta 1 delta will differ when you are choosing the same epsilon. When it is taking the epsilon as some fixed epsilon, and for that taking the continuity concept, then you can able to find delta, but it may be delta is different for each and every point. Okay, so if somehow, if there is a possibility, if there is some function which is continuous as well, uh, if we just choose epsilon, and for every point we can able to get same delta, or we have a delta, we have an same delta for every epsilon, then we can say that function is uniform continuous throughout the interval. So this is a basic difference. So it means that in a continuity, when we are considering some epsilon, and for that we want a delta, we can able to find that delta. So that delta is depending on epsilon as well as the point as well. What where we are want to continuity of the function, तो उस point पे भी वो depend कर रहा है. So if throughout the interval it is the delta is only depending on epsilon, not depending on the point where we are taking care of continuity. Okay, so that type of function is called uniform continuity. Okay, we next we discuss some theorem, some results, some more theorem. But first we understand what meaning of the uniform continuity. Okay, so it means that for the continuity of a function at a point or throughout the interval, we at a different points we have different deltas for the same epsilon. For the uniform continuity, we choose some epsilon, and for that epsilon, we have a fixed delta throughout the interval. Whatever the point we are taking, whatever we are taking care of the continuity at the point. Okay, so it is not depending on the point throughout the interval. So that type of continuity, or that type of function is called uniform continuity. Okay, so I think you understood well what meaning of the uniform continuity. So, so if you are just defining the formal definition, so how we define it the formally? So let's define it. So you can just have, it's just writing here in continuity. In continuity, uh, delta depending on depending on uh, depending on epsilon and point C. This is a general point C I'm just mentioning here. But for for uniform continuity, this delta uh, only depends on epsilon, not on not not on. It's not depending on the point. Okay, so you can easily say this delta is somehow you can look like this delta epsilon. It means depending on epsilon. And here you will, when you are writing the delta, you can writing like this. The delta depending on epsilon has been called this point. So this is the notation in some authors used. Okay, so let's the formal definition of the uniform continuity. So definition. Uniform continuity. Okay, so if a function, I'm just stating if a function f defined on this interval, defined on an interval in interval I is said to be is said to be is said to be uniform continuity, uniformly continuous continuous on I if to if to each epsilon there exists delta which is depending on epsilon only such that mod of fx2, there are the 2 point fx2 and any two, we were taking any point, this is x1 x2, any point, okay, from the interval x1 and x2, this will be less than epsilon. For arbitrary points x1 and x2 from the interval. So if you choose any 2 points from the interval, that there the difference between the values of the functions, okay, is less than epsilon. Okay, and for which we are taking in such a way, this is mod of x1 minus x2 is less than epsilon. If you are choosing any point in such a way their difference is less than epsilon, then the difference will be their values of the function will be less than epsilon. So here we can have arbitrary point. So it means that the dependence of this delta is not including the points. It's not depending on the point. Okay. So this is the uniform continuity, the formal definition. A function f defined on an interval I is said to be uniformly continuous on I if to each epsilon there exists a delta such that mod of fx2 minus fx1 is less than epsilon for any points x1, x2 such that mod of x1 minus x2 is less than delta. Okay, so this is the definition, and what meaning is actually the delta is not depending on the point throughout the interval. So this is the that type function. It's called a uniform continuous, and in continuity, it depending on the points as well. Okay, so आइए कुछ थ्योरम्स और रिजल्ट्स की बात कर लेते हैं और उनके प्रूफ्स भी हम लोग लिखेंगे. तो आइए, बहुत अच्छे अच्छे रिजल्ट्स हैं हमारे पास. So we can have black one. It's taking black one. Okay, so let's write the first theorem, result. If a function is uniform continuous, then that function definitely will be the continuous, because it's also have the definition of continuity. Okay, so definition. Let us prove this theorem. If a function is uniform continuous, then it definitely will be the continuous in that interval. Okay, so if I'm writing the theorem, a function which is uniformly continuous on an interval is continuous on that interval. Okay. So what we have to prove कि there will be continuous in on that interval. तो अगर हम एक यूनिफॉर्मली कंटिन्यूअस फंक्शन लेके चलते हैं तो हमें दिखाना है कि वो कंटिन्यूअस भी होगा एवरी पॉइंट. ठीक, तो फॉर दैट अगर हमें कंटिन्यूटी प्रूव करना है, इट मीन वी हैव टू चूज एनी जनरल पॉइंट फ्रॉम द इंटरवल, एंड दैट पॉइंट वी हैव टू शो दैट इज फंक्शन इज कंटिन्यूअस. ओके, so let's for proof we are choosing the blue color from the this one, choosing the dark blue. Okay, so proof. I'm just writing the proof of this. Okay, and you remember this thing. If a function is UC, then it definitely will be C. It means continuous. Okay, so and this how we writing a formal proof? We just have a function which is uniformly continuous. Then it will be certify the definition of uniformly continuity जो लिखी हुई है हमारे पास ऊपर, और उस कंडीशन को लेकर हम उसे शो कर देंगे कि दैट इज आल्सो कॉन्टिन्यूअस एंड इट आल्सो satisfy the condition for the continuity. Okay, so I'm just writing here, let a function f, let a function f be uniformly continuous. Uniformly continuous on an interval I. Okay, so that it satisfy the condition, so that for a given epsilon, positive, there corresponds a delta such that we have this condition f of x1 minus f of x2 is less than 50. Okay, this condition we have, and we know that where we x1 x2 are the arbitrary points, so where we can have where this x1 and x2 or any points of R for which we have for which mod of x1 minus x2 is less than 10. This condition for the uniform continuity we have. ओके सो अब हमको क्या प्रूव करना है कि I'm just taking this I'm taking this x1 it's any point it means any fixed point okay and this you know that is x1 and x2 both are arbitrary so both are we are taken from throughout the interval it means both points are the general point from this interval okay so if I'm just want to if I'm just if you want to just take in any point if I'm just taking this अब हमें एक जनरल पॉइंट पे हमें देखना है तो अगर हमने कहा कि वो जो जनरल पॉइंट है x1 वो c है ना या फिर सपोज दैट कि हमने इसको x कह दिया इफ आई एम जस्ट टेकिंग this x1 is just equal to x so looks like a function is f of x minus f of x2 टाइप का है ना तो यहाँ पर x भी जनरल पॉइंट है और x2 भी जनरल पॉइंट है तो अब अगर हमने कहा कि x2 एक सिंपल पॉइंट है या x2 इज इक्वल टू हमने c मानो सपोज दैट मान लिया तो हम सी पॉइंट पे क्या कैलकुलेट कर रहे हैं कॉन्टिन्यूटी देख रहे हैं मतलब एक जनरल पॉइंट पे तो इसको थोड़ा सा फॉर्मल लिखते हैं हम समझने के लिए हमने रखा था यहाँ पे अच्छा इसको हमने थोड़ी देर के लिए लिख तो अब जस्ट टेकिंग लेट I'm just taking let this x is a point is belonging to C then on taking this as x1 is equals to ओके x1 की जगह पर आप x रख दीजिए तो आप देखिए तो we find that for xylem positive there exists delta such that this condition will be hold above condition so f of x minus f of x2 is less than epsilon when you can say when this is mod of x minus x2 less than delta अच्छा अब हम ये कंडीशन को देख के क्या ये नहीं कह सकते कि दिस फंक्शन इज कॉन्टिन्यूअस एट द पॉइंट x2 बिकॉज x कंडीशन यही होती है ना अगर हम पहले सी पॉइंट पे कहते हैं कि फंक्शन इज कॉन्टिन्यूअस इन द पॉइंट सी तो हम क्या कहते हैं दिस इज सिंपली वी आर सेइंग लाइक दिस कि मैं से कहते हैं ना मॉड ऑफ एफ एक्स माइनस एफ सी is less than epsilon when this is x minus c x minus c is less than delta ये कंडीशन होती है तो यहाँ पर c पॉइंट है तो x2 है but x2 is an arbitrary point so it will be moving throughout the interval it means this condition will be true for all these x2 all the point from this interval it means function is continuous in throughout the interval and each and every point of the interval it is continuous so you can easily say this is continuous in this interval I. Okay, so you can have you have the condition. What will be the condition that you can? So अगर ये condition fulfill होती है, तो you can easily say. So hence you can say this function is continuous. Hence the function and the function is continuous. Is continuous at every point in x2 which is from the R. Okay, so because it is continuous at every point then you can say the function is continuous. So function f is continuous on R. Okay, so this is simply a uniform continuous we have proved that is a uniform continuous function will definitely continuous. But a continuous function is not necessarily it will be uniformly continuous. But for because you know that for uniformly continuous function it is necessary then epsilon only depending on the or this delta is depending only on epsilon, not any point. Okay. तो आई होप कि आपको यूनिफॉर्म कॉन्टिन्यूटी का कॉन्सेप्ट समझ में आया होगा कि यूनिफॉर्म कॉन्टिन्यूटी कब होती है और कब हम यूनिफॉर्म कॉन्टिन्यूस कह सकते हैं किसी फंक्शन को। तो एक थ्योरम और प्रूफ लिखेंगे और भी रिजल्ट्स हैं, बट एक और मोस्ट इंपॉर्टेंट थ्योरम का रिजल्ट का लिखेंगे। हम यहाँ पर बोल दे रहे हैं बट उसको हम नेक्स्ट लेक्चर के अंदर रिकॉर्ड करेंगे। अ फंक्शन विच इज कॉन्टिन्यूअस ऑन अ क्लोज इंटरवल, अभी हम कॉन्टिन्यूअस की बात कर रहे हैं। A function which is continuous in a closed interval, अगर फ्लो आउट क्लोज इंटरवल फंक्शन कॉन्टिन्यूअस है, हर एक पॉइंट पे कॉन्टिन्यूअस है, that function will be uniformly continuous in that interval. Okay. In general, a continuous function is not necessarily will be uniform continuous, but if that is defined in a closed interval and the function is continuous each and every point of this closed interval, it means the function is continuous in the closed interval, then that function will definitely uniformly continuous in that. Okay, so this theorem is most important theorem and we will prove it कि कैसे हम देख पाते हैं कि अगर कोई फंक्शन कॉन्टिन्यूअस है किसी क्लोज इंटरवल के अंदर तो वो यूनिफॉर्म कॉन्टिन्यूअस भी बन जाएगा या यूनिफॉर्म कॉन्टिन्यूअस भी होगा। ओके, तो वी विल मीट इन द नेक्स्ट लेक्चर एंड दैट लेक्चर इज मोस्ट इम्पोर्टेंट बिकॉज हम एक ऐसे रिजल्ट का प्रूफ लिखने जा रहे हैं जो बहुत ही इंपॉर्टेंट रिजल्ट है। तो आप लोग जरूर विजिट करिएगा नेक्स्ट क्लास को और आप पढ़ते रहिए अच्छे से। थैंक यू सो मच।